Greetings everyone. We are the Group 3 and we are going to present Experiment 3 entitled Purification of Benzoic Acid by Recrystallization. Our group members are Estrella Shaira G, Franco Isaiah Miguel P, and myself, Indunan Juan Miguel J. As for the tasking, the abstract and intro will be discussed by Indunan Juan Miguel J, while the methods will be discussed by Estrella Shaira G, and lastly, the conclusion and recommendation will be discussed by Franco Isaiah Miguel. The objectives of this experiment is to explain how recrystallization was used to purify a substance and understand its underlying principles. The second one is to determine the most suitable solvent. And lastly, the last objective is to explain what is meant by the conducted experiment.
Abstract. Recrystallization is one method that can be used in order to purify solid impure organic compounds. This then assures the integrity and accuracy of the experiment or procedure. Moreover, the purpose of these experiments were to determine the best recrystallization solvent for the purification of the impure benzoic acid by recrystallization and to evaluate its effectivity as a purification technique. The most suitable solvent must be determined through experimenting which among the solvents given shows that the benzoic acid is insoluble at room temperature, while its solubility increases as temperature increases, followed by the next step, which is to recrystallize impure benzoic acid. Consequently, as benzoic acid is insoluble in the solvent at room temperature, and as the temperature of the water increases, the solubility of the solute also increases. The results from the determination of the best solvent from recrystallization of the benzoic acid showed that the benzoic acid was dissolved best in water at room temperature, and the benzoic acid was both insoluble in ethyl alcohol and hexane. Furthermore, at temperature high, both ethyl alcohol and hexane can dissolve the benzoic acid, but hexane evaporated very fast, and no solvent was left after. This makes ethyl alcohol the ideal solvent for recrystallization of the impure benzoic acid. And lastly, the percent recovery of the impure benzoic acid was 9.98% of the 500 mg of impure benzoic acid. In this experiment, benzoic acid was used for it is the simplest aromatic carboxylic acid, which is containing carboxyl group bonded directly to the benzene ring. It was also stated that at room temperature, it can be observed as a white crystalline organic compound. Furthermore, benzoic acid is poorly soluble in cold water and highly soluble in hot water. The process of recrystallization relies on the difference of the solubility of the desired compound and the impurities. This denotes that the solvent needs to dissolve the desired substance when subjected to high temperature, but it should not be able to dissolve the desired substance when the temperature is low or is just at room temperature. Further, this just supports the requirements in choosing the ideal solvent for purification. We suggest that it should be insoluble in room temperature and it should be soluble when subjected to high temperature. Purification is a process that is used in order to separate a compound of interest from the impurities that affects the efficiency or yield of the experiment. The purification process can be done by using different techniques such as sublimation, extraction, chromatography, and recrystallization. However, in this experiment, the researchers focus on the use of recrystallization as a means of purification of the impure benzoic compound. Recrystallization. Recrystallization is also known as a fractional crystallization and is a procedure that is used to purify mostly solid impure compounds in a solvent. If properly done, recrystallization is one of the best methods to separate and purify compounds. The control of impurities is a critical issue in the pharmaceutical industry, and very strict regulations related with this issue have been introduced by the ICH, or the International Conference on Harmonization. In the medical and pharmaceutical industry, producing and utilizing pure substances is of great importance, for the slightest mistakes can lead to adverse effect for the consumer of the medicine. In addendum, the control of the impurities is also an issue of great relevance in the pharmaceutical industry, which serves as the reason why experts always introduce innovative ways and regulations to address the said issue.
The methodology for this experiment is divided into two parts. The first part is the determination of the best solvent. A pinch of pure benzoic acid is placed in 3 separate 10 ml test tubes. then eventually added, each with 5 ml of hexane, ethyl alcohol, and distilled water. The mixture was swirled in order to see and compare the relative amount of benzoic acid in the three solvents. After that, the three different test tubes were placed in a water bath and then heated up to 70 degrees Celsius. The solvent which completely dissolved the benzoic acid will be chosen as the most suitable solvent which will be used for the next method. The second method is the recrystallization of the impure benzoic acid. In a 50 ml beaker, a 500 mg of impure benzoic acid was weighed on an analytical balance. A 10 ml of the selected solvent from the previous method, a pinch of activated charcoal, and a boiling chip was added in the weighed beaker. The beaker is placed on a heating plate and bring to boil with constant stirring until the solutes were completely dissolved. Adding an additional significant amount of solvent is allowed, if deemed necessary. On another 50 ml beaker, a Hirsch funnel was placed above it with a cotton above its hole. The heated solution was poured to it to collect the filtrate. The hot saturated solution was allowed to cool and then eventually placed in an iced bath. On a new weighed filtered paper, the hot crystals were collected. The beaker was rinsed with ice-cold distilled water. After it was rinsed, the remaining crystals were collected and then placed in the heating oven for an hour for it to completely dry. After it has dried, the filter paper with benzoic acid crystals were weighed on an analytical balance. The percentage recovery was then computed.
For the results, at room temperature, impure benzoic acid is insoluble in distilled water, and at high temperature, it is soluble in distilled water. Therefore, the ideal solvent for the recrystallization of impure benzoic acid was distilled water. The weight of impure benzoic acid was 500 milligrams. The weight of pure crystals formed was 49.9 milligrams, resulting to a percent recovery of 9.98%. The weight of pure crystals was determined from the difference of the weight of filter paper and the weight of the filter paper with residue, 1,760.7 milligrams minus 1,710.8 milligrams, resulting to a result of 49.9 milligrams. The percent recovery of the weight of impure benzoic acid recovered was divided to the weight of the impure sample, then the quotient was multiplied by 100. Impure benzoic acid was dissolved in water. It was essential that a minimum amount of solvent should be used. Adding too much solvent will yield an unsaturated solution, making the amount of purified benzoic acid reduced. Colored solutions, which can be an indication of impurity, should be decolorized with the use of activated carbon. Boiling the solution, then filtering it immediately, removes the impurities that are insoluble in water at high temperature. The benzoic acid, which was highly soluble in water at high temperature, remained in the filtrate. Cooling the solution, then filtering it, gets rid of impurities that are soluble in water at room or low temperature. At low temperature, benzoic acid crystallizes. It was important that the cooling process should be slowed to produce medium-sized crystals. Small, less definitive crystals from when the solution if cooled fast. Drying and heating the filter paper in the stove ensured accuracy of results. Crystallization never yields a 100% pure substance. Incomplete dissolution of the impure sample and excessive amount of the activated charcoal would have resulted in lesser yield. Losses could have occurred from the transferring of solids of filtered solution. Prolonged or any contact of the solid with water that was not ice cold could have led to dissolution of benzoic acid. An excess of the recrystallization solvent may have caused loss as well. Rapid cooling of the solution and weighing in completely dried filter paper would have led to greater yield but inaccurate results. The low percent recovery of 9.98% obtained by the group could be explained by several factors. Now for the conclusion. By the end of the experiment, the objectives were met, which were to purify an impure benzoic sample by using the crystallization process and to calculate the percent recovery of the impure sample to determine its purity. Based on the gathered data from the experiment, it was concluded that water was the ideal solvent because it was insoluble at room temperature and the compound was soluble at high temperature. Given the percent recovery of 9.98%, recrystallization was not a perfectly efficient method of purification. It cannot separate compounds of almost equal solubilities and was very susceptible to experimental errors, which may possibly lead to inaccuracies in the recovery of the pure sample of the substance being recrystallized. Nevertheless, recrystallization was still of great use for it was easy to execute and ensures a notable increase in the purity of the final product. The group also have concluded that activated charcoal also filtered some of the impure benzoic acid. Some of the impure benzoic acid cannot be gathered from the previous process. That was why the percent recovery was so small. For the group's recommendations, in the dissolution of sample, use near boiling water. On the other hand, use ice-cold water to aid the complete crystallization and minimize inaccuracies in crystal amount recovery. If done successfully, this would allow to produce larger crystals, which is very much favored in this experiment. It must be carefully noted that only enough activated carbon must be added to the solution for decolorization and the removal of impurities as to prevent the adsorption of the actual compound itself.
For your reference, please refer to this slide to see all the literature that we cited in this study. In addition, these references are cited in APA citation format. And that is it for our report. Thank you for listening.